All right, in this video, I'm looking at section 13.4, costs and advantages of home ownership. The main thing we're going to be doing in this section is looking at fixed rate mortgages and how to calculate what your mortgage payment would be. So when you get a loan for a lot of money for a long time period, like 15 or 30 years, for the purpose of buying a house or some other kind of real estate, like a lot or a piece of property, where the property is your collateral for the loan, that's called a mortgage. Okay? The time until you finally pay it all off is called the term. So like 15 years or 30 years, that would be the term of the mortgage. The down payment is going to be the part of the cost of the house, of the purchase price of the house, that you pay up front, pay initially. Normally some sort of down payment is typically required. And then the principal amount of the mortgage which is the amount borrowed, is found by taking that down payment away from the purchase price. So that's a lot like what happens with our installment loans in a way, back in the previous section. All right, now, a fixed rate mortgage. With a fixed rate mortgage, the interest rate remains fixed, remains constant throughout the term of the loan. So if your loan is for 15 years or 30 years, the interest rate isn't going to change from one year to the next. Okay? And the initial principal balance and any interest that you wind up owing is repaid to the lender with regular periodic payments, usually monthly. So it's, again, a lot like the installment loans back in the previous section. Okay? That process of paying off what you owe together with the interest you owe using regular periodic payments, that's called amortizing. Amortization is the noun for that. So we're going to amortize. Amortization is this process. And we're going to wind up amortizing the loan. All right, so how much your regular payment turns out to be just depends on the amount financed, how long the loan is for, like is it 15 years, 20 years, that sort of thing, and what the interest rate would be. All right, now there is a formula. You'll be given the formula. You don't have to do that. You just need to know how to plug it in. And it uses some of those same letters that we had back in previous sections. You know, the P is the amount that you're going to have to be required to pay back, like the amount that you borrowed. So the monthly payment is found using this formula. So the P is going to be the principal or the how much you borrowed. Okay, the R is going to be the interest rate written as a decimal. T is going to be the term of the loan. And if we use this formula, we'll come up with what the monthly payment would be. Okay? All right, so let's take question number 1. Let's use the formula to find this month, the monthly payment needed to amortize an $80,000 mortgage. So you took out a loan amount for $80,000. The house might have been priced higher than that, but you already paid a down payment. Okay? And then 6% annual interest, 25 years. So to get the regular monthly payment, you're going to plug in the $80,000 for P. You're going to put in the 6% as a decimal where R goes. So remember how that's 0.06. That gets divided by 12. All of that is divided by 1 minus, and then watch all the parentheses when you're typing this in, or make sure that you get it kind of set up this way. And R, remember, is the 0.06, and then that exponent 12 times t, 12 times 25 there. Now, before you type it in, you definitely need to work out the 12 times 25 so that things are done in the proper order. And then you really need to pause the video and try this to make sure you know how to enter this correctly on your calculator. Okay? So you can type it in one step, but you're going to need some extra parentheses to make sure it's doing what you mean. So that's what you've got to practice. Okay? So remember that over 12 is the same as dividing by 12. And then down here, make sure you at least work out the 12 times 25 and make sure that you have those parentheses that tell your calculator that just that 12 over 12 plus 0.06 is being raised to the 300 power. Okay? So I'm going to take a moment to do that, calculate that, and you should too. Okay, these can be a challenge to enter. That's why this formula is a little bit unwieldy. So we're all working to calculate this. Okay. All right, and when you're done, you should get $515, about $515.44. All right? All right, and then when I typed it in, I realized another thing that would really help is if right there where you had 12 plus 0.06, if you went ahead and just added those, since those are beneath that horizontal fraction bar, and just wrote it as 12.06, you'd be more likely to get that entered correctly. So on my calculator, which does not stack the fractions, I actually needed to take that 80,000 times the 0.06 divided by the 12, okay, divide that by, and I had to put in some extra grouping symbols. Let me do those in a different color, okay. So I had to put in this extra grouping symbol for that denominator. Then I had to do 1 minus the 12 divided by the 12.06. That 12 times 12.06 is what's raised to the 300th power. It's not that entire denominator. So that's why these grouping symbols can really get you into trouble. Okay. All right. And then just for the sake of things, okay, think of the numerator. This horizontal fraction bar really means all of that divided by all of that. Okay. So that's how I had to type it in. If you've got the multi-view, you may be able to do that without all the extra grouping symbols. So you can practice that a little bit. Good news though, you don't always have to use this formula. Okay. So if we're given this information, you identify the P, the T, oh, it's supposed to be just an arrow, the T, and the R, okay? And then you just plug it in and evaluate. All right, so here on the next page, I'm telling you that there's a lot of other ways of calculating the monthly payment. There's one in particular that you need to learn how to do that uses this table. So this table gives you what the monthly payment would need to be to repay the principal and interest you would owe for a $1,000 mortgage for various interest rates and terms. So we're going to learn how to use this table to answer question number 2. Okay? So it's really the same question. We have an $80,000 mortgage. We have 6%. We have 25 years, just like we had before. Let me just underline those instead of point to them. All right, but here's what you do if you're using the table. You find your 6%, you find your 25 years, and you look at under the 25 years and you look across from the 6 and you pull that factor out of the table. All right, and that's really a dollar amount, so that's about $6.44. What that factor would be is how much you would have to pay every month for 25 years in order to pay off a mortgage of $1,000. Well, we actually borrowed $80,000, right? So this is really $80,000. That factor, that about $6.44, is what it would take to pay off $1,000. So all we need to do is multiply that by 80. And when we do, we get the same thing we got with that formula. Okay, much easier. You're always going to want to use the formula unless you can't. Okay? So the formula is going to be able to be used anytime I have an interest rate that is like 5.5, 8, 8.5. It has to only be either ending in a 0.0 or a 0.5. And when the term of my mortgage is something divisible by 5, 10, 15, 20, that sort of thing, okay, which was often, okay. All right, so let's look at one more problem here, two more problems, one more problem with two parts. All right, when you're looking at this, I'm being asked to do two things. I'm asking you to find out what your monthly payment would be. And then I also want to know how much interest did you wind up paying overall. Okay, so getting the monthly payment is what we did earlier. If you look at Part A and Part B, notice on Part B that I could use the table. See, the interest rate is nice, okay, and the term. Both of those are in the table. So here I can use the table. But on this one, the interest rate, it's not a 5 or a 5.5, it's 5.2. So this one I'm going to have to use the formula. So your first step is going to be to get what the monthly payment would be. Okay. All right, so I'm ready to plug into that formula. So you go look at the formula. The R on the left stands for the regular monthly payment. Okay, so we're just looking at that formula from earlier. So 145,000. Then we're going to multiply that by 0.052 divided by 12. Then all of that would be over 1 minus 12 divided by, and here I'm going to have 12 plus the 0.052, but I could go ahead and add those and get 12.052. But then that fraction right there would have to be raised to the 12 times 25. Okay, so right here, that 12 times 25, you would want to go ahead and work that out. Okay, so that's 300. Now let me go ahead and back this up since I'm going to do that. So when I strictly use the formula, it looks like this. Okay, and then clean it up a little bit before you go type it into the calculator. But like taking the 0.052 divided by 12 and rounding is not a good idea. You don't want to do round until the very end. But it would be good to go ahead and add the 12 and the 0.052. Make sure that's clear. And then that would get raised to the 300 power. I would do that much before I go type it in. Then be careful. You may need extra grouping symbols depending on your calculator to make sure that you get that typed in correctly. And when you work that out, that turns out to be about $864.64. Okay. Now that right there is just what the monthly payment would be. That's this answer. Okay, so that's the first part. I'm going to go ahead and give myself a little more room. Sorry I didn't give you very much. Let me see if I can move this down a little bit. Okay. All right. So after we get that, that's the regular monthly payment. So that's the payment that we would have to make every single month for 25 years. So to get the total of all of those payments, couldn't I take that monthly payment, multiply that by 12 for 1 year's worth, but I'm going to do that for 25 solid years. So when you do that, and let's work that out, so that's 864.64 times 12, oops, I didn't type it right, $864.64 times the 12 times the 25. Okay, that means by the time I get to the end of this loan, I will have paid them back $259,392. That's the total of all of those payments over the life of the loan. So I borrowed $145,000. I paid back $259,392. So the difference between those would be the interest that I wound up paying. Okay, so I'm going to take that and I'm going to subtract that $259,392, and I'm going to subtract the loan amount, the principal, from it, and that tells me how much interest I wound up paying. I paid an extra $114,392. Okay. It's usually a little surprising when you do it, maybe a little scary at how much interest you wound up paying. You paid a lot of interest for just a $145,000 loan. All right, let's try another one. But what I did on the second one, remember, is I made it a little easier to calculate the monthly payment. I'm going to move it even a little further down. Okay, so on part B, we're able to use the table because of the percentage and the term being nice. Okay, so we're going to go to that table. And we're going to look for the 5.5 and the 20. So I'm going to go back here to where I have the 5.5 and the 20, and I'm going to look at the factor that's in that fits both of those conditions. So that's the 6.87887. So that factor, 6.87887, so about $6.88 is what I would have to pay every month for 20 years in order to pay off this mortgage. Okay? So I didn't just borrow, no, I said that wrong. That $6.88 would be the monthly payment I would have to pay every month for 20 years to pay off a $1,000 mortgage, but this is a $200,000 mortgage. So that's 200,000s, right? This is what you pay for a $1,000 mortgage. So I'd need to multiply that by 200, and that would give me what my monthly payment would be, my regular monthly payment. It would be $1,375.77 every month for 20 years. Okay? So think about that. If I pay that amount every month, then times 12 tells what I paid them in a year. And then if I multiply that by 20, because the term of the loan is 20 years, that would say how how much I paid back by the end of those 20 years. Okay. So I'm taking the 1375.77 times the 12 times the 20, and I wind up getting $330,184.80. That's the total of the payments over the life of the loan. So to calculate how much interest was paid, I just need to take the total amount I repaid minus the amount I initially borrowed. So when I subtract the $200,000 from that, that $130,184.80, that's the extra amount I paid them above and beyond the amount borrowed. So that's the interest that I paid. So $130,184.80.